Good day, everybody, and thank you for joining. This is a very interesting topic, or a thorny problem for a lot of our customers. And it's a topic that's been around for a long time, but there's kind of a resurgence in interest in this. And what we're going to talk about today is how to avoid outage risk and lots of operational costs by doing a SONET to packet network modernization. Before we start, just a little bit about Ribbon Communications. Ribbon Communications is a provider of real-time communications solutions like voice and also packet optical transport solutions. The packet optical piece of Ribbon comes via an acquisition merger of the company ECI that was completed in March of 2020. So if you're familiar with ECI, all the packet optical portfolio elements are from that. Our packet optical transport portfolio is a leader in deterministic forms of transport. We've offered many solutions for critical infrastructure companies such as electric utilities and also for service providers. We have a full layer 0 through layer 3 solution portfolio, including things like carrier Ethernet networks, IP MPLS networks, OTN and ROADM networks deployed around the world. And in this topic today, sort of TDM or SONETISDH migration solutions, we have over 100,000 circuits deployed in networks all over to solve this kind of problem. With the Ribbon and ECI merger, ECI was headquartered in Israel. We still have a major presence there, obviously, but now with the Ribbon merger, we are headquartered in the United States. Combined revenue of $900 million and 1,000 patents, and we're traded publicly on the NASDAQ stock exchange. So that's a little bit about who we are. Let's talk more about today's problem. As many of us on the call probably know, SONET and SDH were just wildly successful. I made my early career in the SONET world, as did Todd Sibby, my colleague here. It's been around for really 30 years. It's kind of like McDonald's, billions and billions served. There's a couple million nodes deployed around the world, billions of dollars spent in this technology. A whole bunch of different kinds of equipment used this, add drop muxes, cross connects, channel banks, M13s, not SONET per se, but still TDM, and big, little, medium sizes. It's just kind of crazy what's out there. And it served dozens and dozens of applications, everything from sort of shared inter-office infrastructure, long-distance networks, access, voice, data, video, mobile backhaul, business services, residential. Broadband back in the day was not really very broad, but SONET was used for backhaul of the residential broadband traffic. Really the ideal technology for its era, for a universe that was built around an N by 64 kilobit kind of voice-based multiplexing hierarchy. Not exactly today's world, but it was today's world for a very long time, and there's a lot of this stuff out there. A lot of the SONETISDH equipment, and this is such an interesting problem. It's finally sunsetting, and to a degree, it depends on whose equipment you have. If you had SONETISDH equipment from a highly reliable vendor, that network may not be experiencing any problems. But there's lots of different vendors out there, and some of this equipment is starting to have some troubles as these networks are end of life, end of service. One of the common problems that we see when talking with customers is just the difficulty getting spares. And so people are resorting to things like eBay. I don't mean to make a joke about this because people are suffering, but people are looking for spares. In the under-desk local warehouse, that happens. And actually, there are cases where I've seen this a couple of places where there's multiple organizations in a single service provider, and those different organizations built different SONET networks for different things, or SDH networks for different things, and sometimes they're competing with each other for the few spares that are left. So it's just a really tough situation right now. A lot of the vendors that are still supporting their SONET gear have raised the prices, and the price of maintenance and the price of support has gone up, so those costs are now a lot higher than they used to be. Sometimes there's special expertise required to engineer or deal with a SONET or SDH network, and those things are space and power hungry. So there are cases where people have plenty of room in their offices. There's cases where people don't have room in their offices, and it's just tough. So right now, these networks have been around for a long time. They're becoming operationally costly, and they are becoming, in many cases, a large outage risk. So even though the equipment is approaching end of life, and the equipment is kind of becoming an outage risk, the TDM interfaces and the service requirements are actually kind of sticking around, and that makes for a very awkward problem. This is just a couple of the examples that we've seen in talking to our customers. One example is kind of voice trunk interconnections between carriers. So this picture says, well, if I'm the service provider here and I'm delivering a voice service, I need to hand off voice trunks to maybe even more than one ILEC that I'm close to. And a lot of those trunk handoffs are at DS3s and DS1. So I have to have a DS3 interface on the edge of my network and hand off a DS3 interface at the or DS1 to whatever ILEC I'm interfacing with. Even though I have the capability to run like SIP trunks or something like this, there's actually both in the US and in Canada, there are financial and regulatory incentives to maintain the DS1 and DS3 handoff at those locations. So the endpoints are going to be fixed. How do I provide an infrastructure that can deal with those legacy endpoints, but do it in a maintained network? The second case is, business customers, maybe small, medium business or large enterprise in some case, who actually still want their DS1s, their DS3s, and their SONET circuit handoffs to the service provider. It's been actually probably a decade-long activity for many service providers to sort of encourage their enterprise users to move away from TDM private line circuits and to roll toward Ethernet. But there may be some reasons why that's just not convenient for the enterprise, or maybe they have some special front-end processing application that doesn't really work well over Ethernet. There are a few of those out there, so for whatever reason, the customer still wants to interface to the service provider with a DS1, a DS3, or a SONET circle. So the SONET service. So the problem is then how to satisfy the interface requirements and the service requirements while replacing the infrastructure. Now, part of the reason why this problem sort of fascinates me is this technology, to keep the endpoints at TDM and replace it with a more modern network. That technology has been around for quite some time, and you're probably familiar with it. It's called circuit emulation, and in layman's terms, what that does is chops TDM circuits into packets, and then the other end of the network, it reassembles those packets back into TDM circuits. There's many standards for this, and you can look at the dates on the standards documents and see, okay, that stuff's been around. There's the SATOP standard, which is done by the IETF, 2006. There's the CES-PSN standard, again done by the IETF in 2007. There's MEF8 that was done way back in 2004. I still had 4 little kids running around the house back then, and it's not the case now. So these standards have been around for a while, but I think that the problem was maybe the initial positioning or the motive for those standards. There wasn't always such a great business case for implementing the stuff. It was kind of, at least what I remember hearing back in the day was, hey, you can save a lot of bandwidth. If that TDM is not fully used, or the DS3 more likely is not fully used, I can chop that DS3 into packets and really be efficient with the level of bandwidth that goes to the network. And there just wasn't always a great business case for that. The other thing that people talked about was a kind of convergence network. So, I'm just going to lump everything on a single network. And it sounded great on paper, but it really wasn't done a whole lot to my recollection. It did find a home in critical infrastructure modernization, in a lot of critical infrastructure like electric utility environments or oil and gas environments. They have things called SCADA systems for collecting telemetry data from very sensitive things like substations and transformers. And those SCADA systems were kind of like DES type of circuits, 64 kilobit data things. And circuit emulation was actually used successfully to deal with that kind of traffic over a packet network. So that's been going on for a while, but it never really took off for service provider infrastructure modernization because it was never historically quite the right business case or the right focus. But now, this is just really, really tough. I talk to customers every week, sometimes multiple times a week, and have just started bringing up, hey, are you having a problem with TDM network modernization? And I have not run into a customer that has said no. They said, yeah, we're really starting to look at that because kind of our backs are against the wall. We don't have any spares. I hear that over and over and over again. So you can kind of make a business case then for replacing SONET-SDH with packet gear. And these are sort of, I'm just throwing horseshoes here. When I started in the SONET world back in the early 90s, you could do, 7.2 gig worth of switching in a half a rack. Okay, and that was state of the art back then. You get some great stuff. Now you can get 300 gig of switching in one rack, and today, if you do the math, that's about a factor of 1,000 space reduction, depending on the generation of SONET or SDH that you need to deal with. Similarly, it was about 100 watts a gig back in the early 90s. Now it's kind of 1 watt per gig, so you're getting about 100 times power per bit reduction. And we have run into customers who are looking at doing expensive power builds in their offices, and it might make more sense just to rip out this gear instead of buying more power and bring in more backup batteries and generators and things like that. There's the cost of maintenance that we talked about earlier. It's a little hard to quantify, but you know it when you're experiencing it. And lastly, it's one of these things, it's the cost of customer retention. There are networks out there that are almost literally out of spares. If they have something die in the network, they're going to have an outage, and you're going to have to explain it to somebody and, go quantify the cost of an angry customer. It's just tough right now. So with that is kind of the background and problem statement. And again, I'm seeing this everywhere that we go these days. Let's talk just briefly about some of the key technologies that solve this problem and dive into a little bit of the guts of circuit emulation. Again, some of you may have been familiar with this for years ago. For some of you, this may be a little bit of a refresher. Probably the leading standard for this is the SATOP standard, which is RFC 4553, came out about 15 years ago. And the idea of SATOP, it's structure agnostic TDM over packet, and that basically you take a complete DS1 and a complete DS3, or an E1 and an E3 for our overseas friends, and put those into a standard MPLS pseudo-wire. And because it's structure agnostic, it maintains all the framing structure of the DS1, all the framing structure of the DS3. It's completely agnostic to the payload, of course. And the idea is it provides sort of bulk transport over an MPLS network. And this is the technology you'd pick for like a SONET TDM replacement, where you're not trying to manipulate the framing bits of a DS1 or DS3 or a SONET DAX replacement or something like this. This would probably be your technology of choice, your standard of choice for doing like an enterprise or a commercial service private line replacement, leased line cost avoidance, and voice trunking. And by the way, Todd Civi, my colleague, will review a lot of these applications in detail that we're seeing later on. But pretty much if you're doing any of these, SATOP is really the simplest way and actually fits the application best. There's another one that's used for higher rate actual SONET circuits, and that's called the SONETISDH circuit emulation over packet. I guess they didn't have a fancy acronym for that. Maybe I should have invented one. That's RFC 4842. And what that does, if you recall your SONET days, you have the SONET line overhead, which is the OC or the STM. Inside the SONET line layer, you have a path layer. For example, in the US, in the SONET world, you'd have STS1. In the SDH world, you have like a BC4. And the idea is that the interworking function here then emulates the SONET path. The line is terminated. It emulates the path, sticks into pseudo-wire, MPLS label switch path, and out over Ethernet. So it looks very much like the SATOP concept, basically taking a DS1 may have a DS0 inside it, but you're not really aware. Inner work at pseudo wire, label switch path, and line side port. So it's the SONET is any kind of SONET path, and of course it's payload agnostic. The little more advanced version of circuit emulation is called CESOPSN. That stands for Circuit Emulation Service over Packet Switch Network, and that provides individual DS0 visibility inside a DS1 or a DS3. With that, sometimes it gets a little bit tricky. If you've been around a long time and have a voice background, you may remember this acronym, CAS, Channel Associated Signaling, sometimes known as robbed bit signaling for voice. In this case, the framing bits actually carry signaling information, and so the CESOPSN, because of terminating the framing, actually has the capability of sort of making up for that and having a way to be compatible with robbed bit types of networks. These are, and you probably need this if you're doing like a 1.0 DCS replacement, you probably need this capability. But if you're doing many of these other applications here, the SATOP function will be just fine, or the SONETISDH circuit emulation will be just fine. Good, hope that helps. And there's one more. I don't mean to leave out I can't call it the Metro Ethernet Forum anymore. It's actually just called the MEF. They rebranded themselves. So MEF 8 has a standard called PDH over Metro Ethernet. It actually came out before the other standards. And the idea would take DS0, DS1, DS3 over Ethernet, not pseudo-wire MPLS in this case, but just over an Ethernet VLAN. And it had, structure agnostic mode that was like SATOP. They had a structure aware mode that was like CESOPSN. And under the under the structure aware mode, they could say you'd run a basic mode or again a CAS aware mode. MEF 8 did not standardize, at least to my knowledge, a SONET path over Ethernet. So if you're going to do a SONET circuit emulation, I believe that would actually need to be over MPLS. And then MEF 3 was kind of a companion document that says, okay, here's kind of the service definitions. It's kind of what MEF did for a living. Here's the service definitions for a circuit emulated circuit over a VLAN. Okay. And then finally, I need to say a little something about synchronization. It's kind of an arcane topic, but it's very important. Packet networks that are doing circuit emulation do need to be synchronized. It doesn't have to be difficult. You can run just plain old SYNC-E, or you can run 1588 V2. I'm sorry, I think that's IEEE 1588 V2. Forgive me for that. That'll work just fine. You don't need very high performance clock stability like you would for 5G transport in the mobile world. You're running SYNC-E or 1588 V2, you're pretty much fine. The sync network then feeds a differential clock recovery mechanism at the endpoints, because when you're taking in these packets and putting back together the DS1, you want the DS1 to have the same frequency when it leaves as it did when it entered. So there's a clock time stamping method that helps you deal with that. And if the network fails at synchronization for some reason, there's usually an adaptive clock recovery that exists in the equipment that'll kind of get you through the night while the synchronization is repaired. So that's a little review then of the overall problem statement. It's pervasive right now, and a little bit of a review of the technologies that can use to serve that. Next up, Todd Sivy will be talking about some of the specific network applications that we've seen. But before we do that, we thought we'd liven things up with a little bit of a poll question this morning. Lance, if you want to show today's poll question.
Yeah, sure thing, Sam. So that should be on your screen right now. We have, please vote for the joke whose punchline you would like to hear at the conclusion of the webinar. So you get 4 choices there. First one there, an infinite number of mathematicians walk into a bar. Number 2, how many people live in Brazil? Number 3, a horse walks up to Sarah Jessica Parker and says, and the last one, what's brown and sticky? So I see some responses coming in. It looks like we have a clear winner at this point. Sam, Todd, if you can see that information rolling in there in the poll section, you can comment on that. But we'll give it just another minute here before we close that poll. Looks like we have about 25% have voted, nearing 30% now.
Okay. Now, my favorite joke isn't winning, but that's okay. The good news is that here at Ribbon, we do lots of webinars, and if your favorite joke didn't win, we'll put it back for the next webinar, and you'll get another chance to vote for it. So, you know, vote early, vote often. That's always. Okay, so let's go to the next section here, where Todd will talk about example use cases and applications.
Okay, thanks, Sam, and thank you again to everyone for joining us today. So at one time and early in its development, the circuit emulation services were seen as a very specific solution that satisfied the need of a very precise problem. And the deployment rate and the usefulness of this application seemed quite minimal. And as Sam mentioned earlier, more recently, due to circumstances around the aging of the network, there has been a wider range of applications for CES that have been presenting themselves. And we'll use this time, the next few minutes here, and slides to go over these applications that circuit emulation can solve and how we see operators addressing these current problems. So I'll go into detail on several of these specific applications listed at the top left of the slide, but the first two really presented themselves as a direct result of the aging of the legacy SONET equipment that we've covered so far. The third item, the third-party leased line avoidance, is something that has strapped operators for years. For the leased line application, we will show how circuit emulation technology can reduce this legacy monthly recurring cost or potentially remove it altogether. Now, as these SONET networks continue to age and become a problem, we feel that more and more CES applications will present themselves. There's a massive amount of legacy SONET networks that are out there today and running just fine. But as projects or segments of the network are upgraded and other applications, we feel that other applications will come out of it and present themselves. So if we have any fans on the line of the red-green show, operators are in a similar position to the famous Canadian handyman, in that their networks are still running well, but the issues and costs will present themselves if not addressed. However, in this instance, instead of trying to fix it with duct tape, operators can address this complex problem with circuit emulation. Due to the size and complexity of most embedded SONET networks, many operators are facing an end-of-life scenario that could take them up to 10 years to upgrade. And rather than tackle it all in one shot, operators find it beneficial to break them up into discrete projects, allowing them to justify the expense and also focus on the older or more problematic segments of their network. And by doing it this way, by doing so, they can also mine spares from the networks that they're upgrading, complete the migrations, and create some relief to the operational costs of the other SONET segments of their network. Okay.
And Todd, maybe I could just sort of interject here briefly. To me, this is one of the most fascinating aspects of the problem, and I think one of the most frustrating aspects for our customers, because SONET was used for so many different things. There's lots of different, let's say, islands or network deployments for this application or that application, and it sort of presents people with the opportunity to segment the problem. Like Todd said, it's really difficult to cost justify a complete network modernization if you have a massive network. The good thing is if you have a massive network, we've seen lots of these networks are so large, it's like their own kind of spares warehouse. So as circuits are decommissioned a little bit, service providers are actually mining those networks and maintaining their own spares. The irony is it's the smaller networks that are often much more at risk because they don't have a big spares domain, and they're more affordable to fix. So they can we're seeing operators kind of go in surgically and saying, okay, I've got this problem, it's tactical, this is my bad problem, I can solve it, I got money for it this year. This other problem, I'm going to have to wait till later to solve that. And they kind of break things up. So I think that's the most fascinating part, is it's the smaller networks that are the bigger problem and the problem that's easier to fix. So that's where we're seeing probably a lot of interest right now. Is that fair, Todd?
Yeah, I agree.
Okay. All right.
Okay. So the first use case example is the voice trunk transport, which has presented itself in many operators that have a legacy VoIP application. Typically in these networks, the handoff to the carriers has been a DS1 or a DS3, and 10 plus years ago, operators could easily solve this transport requirement from the carrier locations or PSTN back to their own central office or hub with a SONET network. And these networks have been delivering this service with no issues for years, but now as the SONET gear is end of life and difficult and costly to maintain, the CES solution presented itself as a way to get off this end of life hardware and onto a solution that will be maintained and developed for years to come. Next slide. Go ahead, Sam.
Yeah, it should be on slide 15.
Okay, there it goes. Thanks. All right, so now here on this slide, we're showing how you can solve this voice trunk transport issue with circuit emulation. So by migrating from a pure SONET infrastructure to a packet-based transport solution, operators are immediately going from an end-of-life solution to a current technology with years of development and product life cycles. And as shown in the drawing, the network maintains their existing DS1s and DS3 handoffs to the ILEC, as well as an OC3 handoff back at the hub for the handoff to the voice gateway for the VoIP connection. However, within the core transport, it's now running over an MPLS or Ethernet-based network while still maintaining the voice-grade transport needed for this service. This blue cloud or transport piece could be a variety of things to meet whatever the operator has existing or has a vision of building in the near future. Most commonly, it's an Ethernet or an MPLS or MPLS TP network, and it could even be a DWDM network with DWDM optics or coherent optics on these CE devices at the edge. Okay. So yeah, that's the voice application, and the next application is a similar problem to the voice transport application presented. But it presented this application presented itself when we started talking with similar customers about their legacy enterprise services. While it's been said for years that SONET is a dying technology, there are surprisingly a large number of enterprise customers that for one reason or another do not want to migrate to a packet-based solution. And there's some people within the operators' organizations that are not eager to migrate these customers that are paying a higher monthly fee for a DS1 or a DS3 service as well. Therefore, operators are faced with the dilemma of how to meet the needs of their customers that want to retain this DS1 or DS3 service, but without the expense of keeping a costly SONET network operational. Similar to the previous example, the circuit emulation solution could include rates of DS1 or DS3 or OC3, but now could also include services like OC12 or potentially even higher rates. It's also now important to provide the support of protection schemes that customers would expect from a SONET-based network. And by migrating from a SONET Edge device to a circuit emulation solution, the customers are getting their required interface, but now operators can transport this service over an existing Ethernet MPLS TP network and thus reduce their total operating costs.
Just one brief comment on this. MPLS TP is kind of an interesting technology. It's taken off in the critical infrastructure space, not so much in the service provider space, but it's got some really interesting characteristics for deterministic transport. And if you're a group of folks who are used to operating a TDM network, and that's what your folks are trained to do, MPLS TP is basically a way to make MPLS look kind of like SONET. It's point and click provisioned. It doesn't use an embedded control plane. You get guaranteed quality of service. So we've got some customers, most folks are interested in the Ethernet or MPLS flavors, but we do have some folks that are interested in using MPLS TP just because it looks so much like SONET and because it fits so much their current operations procedures.
Yeah. Okay. So another benefit seen by introducing circuit emulation to the enterprise access solution was the simplification, an overall simplification of the architecture. Oftentimes, an enterprise location will service multiple customers requiring requiring a variety of interface types. This has resulted in multiple types of equipment carrying a multitude of interface types at an edge location that's already constrained by space and power. So by introducing a packet-based solution that supports traditional Ethernet signals and SONET circuit emulation service on the same platform, operators are now able to reduce the number of boxes at the edge, but maybe even more importantly, also reduce the number of networks they transport over. So going from left to right, you go from 2 discrete networks to a single Ethernet network running both types of services over it. Okay. Okay, and our final use case for CES applications today focuses on how circuit emulation can lower operators' monthly leased line access charges. As I mentioned earlier in the presentation, this has always been a challenge for operators who spend millions of dollars per month on recurring lease charges. The first application shown here on this slide is a problem where service providers are leasing capacity to interconnect their networks. Since the handoffs are TDM today, the lease costs are usually dramatically higher and often contain a mileage component in addition to the price per bandwidth. In this example, service providers have the ability to migrate to a circuit emulation solution to keep the TDM handoff, but convert to a packet-based transport, which leases at a much lower rate, much lower cost, as shown on the bottom drawing. They are now still delivering a SONET interface, but can now recognize a much lower monthly lease rate over a VPN circuit. And on slide 19, another use case to reduce the lease line charges is on the enterprise service, where the service providers rely on third parties to provide that last mile access to the enterprise location. This can be an enormous expense for operators to deliver this SONET interface and burdens the margins on their business. Similar to the previous enterprise example, the service provider is often servicing other customers at the same enterprise location over an Ethernet circuit and are leasing 2 access circuits at an even higher total expense. Therefore, we've seen many service providers eager to introduce a circuit emulation solution, which allows them to eliminate the costly TDM access circuit and gets them to a single lower monthly cost, a much lower cost Ethernet circuit instead. So, I mean, when we present this solution, there's a lot of eagerness to jump on the application because the cost savings alone can justify the expense of the upgrade. There's one last benefit on slide 20.
Okay. Sorry, we're having a little bit of slide delay.
Yeah, a little bit of lag. Yeah. The other benefit I wanted to point out was that the benefit that operators could experience by converting to a circuit emulation solution is that when they migrate from a TDM to packet circuit, oftentimes the operators already have an in-house packet network in place. Therefore, they have the opportunity to eliminate this leased TDM circuit completely and leverage the existing in-house packet network. This cost saving alone of that leased circuit covers the expense of the new hardware, but also removes that legacy SONET gear. And as Sam mentioned earlier, they could use that time or use that network to mine spares for other areas that might be a bigger problem in their network. So again, these are just a few examples. These are a few use cases that are present today that we've seen. And we feel strongly that as these projects are tackled and operators look to continue their migration strategy, we're pretty confident that other applications will become prevalent. And because rarely does one solution fit all applications, we feel it's important to have a range of options that are flexible to meet the various needs. So with that said, I'll hand it back to Sam to cover the solution overview and cover a bit of the modularity benefits of the ribbon solution.
Okay, and thank you, Todd. Well done. And this won't take long, but we do want to show you a little bit of what we specifically do to meet these needs. And of course, there were 2 joke winners, really. There was one with 50% of the respondent, one with 47% of the respondents. And I don't want to be like the Electoral College, but I think it's only fair that they were close, so we'll give you the answers to both jokes. Our Neptune Universal Solution is a little bit different than some of the other solutions we've seen on the market. And I don't want to pick on folks. I mean, there's a bunch of good products out there, but there's one solution that folks may be aware of. It's just Brand X, right? And they have a couple of solutions. They have something that's pretty darn large, and they have something that's pretty darn small. And the solutions come actually from different product families. They have different software, hardware, different operations, big and small, and not really anything in between. We took a little bit of a different, and that becomes a little bit of an operationally complex issue. Got a couple things you got to learn, and you know, what if your need is sort of an in-betweener? Well, which one do I use? And our platform solution for this is branded as Neptune. Neptune is a full-blown Ethernet or IP MPLS solution, depending on which kind of protocol you want to run. And it's a single product family. You can see they even all kind of look the same. Even I get them confused. Now, they all kind of look the same. And what we've done is we have circuit emulation cards, and there's maybe a few of them that you can see here. And those cards go into slots in these chassis. Now, not all the ports on the various Neptune platforms are from slots that go in the chassis. Some, to save cost, some of the Ethernet ports are just right on the blade itself, so it keeps it very low cost. But if you do have a need for something like this, you can just pick the card you need and populate accordingly. And basically, you just have one product family to deal with, and you have some interesting size options depending upon your actual deployment, all the way from microsites to very large node replacements and kind of everything in between. I won't bore you with too many details, but just to flash briefly before your waiting eyes, and this is the Neptune 1010. That's a very small device, one rack unit. It's only 8 inches. It's kind of something you can hold in your hand. And we've got customers who want to do just a few DS1s, not even over a gig E. They actually want to do it over 100 meg because there's cost on the other end, depending on what you're interfacing to. And getting a little bit bigger, this is the Neptune 1022. You can see most of the Ethernet ports are right on the blade, but you know, if you need a little bit of circuit M, you just pop one card in. Maybe one of the most useful solutions is the Neptune 1050. And what makes this kind of interesting is it's still one rack unit. There's still Ethernet ports right in the chassis there, but there's you actually have 3 slots per circuit emulation application. So if you have a mix of DS1, DS3, OC3, and it's too big a mix to satisfy with the little combo card here, you can do that very cost effectively in a 1050. And by the way, I want to apologize. I've been very remiss. I tend to use the terms DS1, DS3 because I'm based here in the U.S. These are also E1, E3, and SDH solutions as well. They're global solutions in the global platform. So that's kind of it for our solutions. And in summary then, SONET sunset. It's for many folks out there, it's time to actually bite the bullet and fix it. You can avoid the high cost of an outage that you can't repair and the cost of embarrassment with your customer. You can start with, as many of our customers are, they're starting with their biggest problem areas first, which are often the small networks that they can afford to fix, and the small networks for which they're out of spares. We have a single Neptune product family that we can use to help with that problem. It is standards compliant and interoperable. It's interoperable with Ethernet, MPLS, MPLS TP, transport profile, and WDM networks. We support the necessary synchronization capabilities, frequency and phase support, SNMP, if you need that, to go to a third-party management system, or we have an NMS system that has some light configurations of a small network called LightSoft. And more importantly, it is an Ethernet and IP services platform that you can deliver advanced services on for many years going forward. All right, thank you for your attention. I'll tell you the jokes here. We'll take some questions. And maybe just before I do, just a quick reminder that this TDM modernization solution is just part of the Neptune series suite of applications that we support, including 5G transport with hybrid slicing that can provide guaranteed isolation for various 5G services and multi-tenancy, which is important for mobile backhaul. We do a lot of 4G mobile backhaul around the world right now. I think some of you folks are listening from overseas. Thank you for joining this morning. Enterprise services solutions, both layer 2, layer 3 VPN, and a big emphasis for us these days, and for folks these days who serve smaller rural markets, is capitalizing on RDOF federal funding for residential broadband backhaul, or maybe capitalizing on your new CBRS license that you just obtained to deliver residential broadband. These platforms are excellent solutions for economical residential broadband backhaul as well, and we'll be having webinars on many of these topics going forward. So again, thank you for joining. The two joke winners, okay, the coming in first place, Horst walks up to Sarah Jessica Parker and says, hey, why the long face? That's terrible, isn't it? Okay, the other one is kind of my favorite. It's 47%. Hey, that's kind of close enough, right? This is election season. 47% to make them feel good. An infinite number of mathematicians walk into a bar. First one orders a pint. Second one orders a half a pint. Third one orders a quarter pint, so on. The bartender just rolls his eyes, brings 2 pints up to the bar and says, oh, you mathematicians, you just don't know your limits. So if you ever flunked calculus, you probably didn't get that. I apologize for both of those jokes deeply. We'll have better ones in our next webinar. And with that, Lance, maybe we'll turn over to Q&A.
Yeah, Sam, sure will. I thought those jokes were excellent. So thanks for offering those up for the audience. So yeah, we have quite a few questions came in. I'll just start with one. I'm not sure what it's referencing, but I'll just say it like it was written. What about interoperability?
Yes, interoperability is a big issue, and there's sort of two flavors of interoperability. One is sort of the interoperability at the box level, where you want to make sure, well, let me put it this way, when you're taking the TDM circuit, you're chopping it into packets, you're putting it into Ethernet VLANs or pseudo wires and MPLS tunnels, you want to make sure that the pseudo wire and MPLS tunnel sometimes needs to interoperate with an embedded Ethernet or an embedded MPLS network. So that's sort of one flavor of interoperability, and the standards are pretty clear, and there's not really much controversy there. What was I going to say? The other type of interoperability is where you're looking at some sort of end-to-end interoperability, where say you've got one vendor equipment chopping the TDM circuits into packets, and you've got another vendor equipment that's taking the packets and reassembling it into circuits. And that's a little bit more tricky. There was a couple of options in the standards. But so you'll probably want to hook that up in the lab somewhere just to kind of make sure it works. We see that as a little bit more of a corner case. The bigger issue, because actually a lot of these smaller networks, they're greenfield networks, and interoperability is not an issue at all. But so the end-to-end one is one you want to check. The non-end-to-end one, where you're interoperating with an embedded MPLS network, you'll want to check that as well, but that tends to be more straightforward.
Okay, thank you. And while I'm going through these couple questions, maybe you guys can look at those questions tab. There's quite a few there we can sift through. Maybe there's one that you think is better to respond to. So here's one that came in. What is SYNC-E?
Oh, okay. SYNC-E stands for Synchronous Ethernet. That's a standard that came out many years ago, and it's basically gosh, if you're familiar with the old SONET networks, SONET or SDH networks are synchronous networks, and the network elements are timed to a bits clock with a certain stratum level, and the SONET timing information is actually communicated in the bit stream itself in the rate of the line. So a downstream SONET node can actually synchronize its frequency clocks off the signal that comes from the upstream line. SYNC-E works kind of the same way, only it's for Ethernet. It's very simple. It's not packet-based. The synchronization is actually carried directly in the line that goes from box to box, and that's a very sufficient way to a packet network to support circuit emulation. That SYNC-E works just fine. That's probably the simplest and kind of original, if my memory serves, timing for packet networks.
Okay, great. Do your products interoperate with Calyx ONTs, T1s over IP emulation? Another question we had.
We would have to verify that. What we can do for you is we can describe the framing and so forth that we do. It's based on those standards I mentioned earlier. And if any other vendor equipment is following those same standards, we ought to be able to interoperate. So, so we'd be happy to help you test that. These nodes are relatively inexpensive, and we can get one into your hands, and we can hook it up and help you with that.
Got it. Let's see here. Are you able to mix MPLS IP and MPLS TP on the same network, or do you need separate equipment for the TP subnetworks?
No, this is actually a unique capability of ours. We actually, in fact, we had a brand name for that. We call it Elastic MPLS. Excuse me, and we support the ability to concurrently run multiple flavors of MPLS, if you will. And that's actually important for some critical infrastructure folks. But if it's important for you too, we can run those things together in the same network.
Okay, very good. Let's see. Going through the list here, we have just time for a few more. Is the circuit emulation solution still a closed solution, requiring the equipment at the ends of the circuit to belong to the same vendor?
No, I think in principle it can be interoperable, but you'll just want to check that. And in principle, it should be interoperable.
Okay, good.
It just so happens that many of the applications we're seeing tend to lend themselves a little bit closed right now, but there are some that are not closed, and it's important that interoperability is important.
Okay. Let's see here. Can a SONET circuit running over CES be used to carry timing between bits clocks?
Ooh. You know what? Let me check on that and we'll get back to you. I don't want to send you astray. That's a great question.
Okay. So Alex, be on the lookout for an answer to that question. Let's see what else we have here. Is the VPN client included on the platform?
Yeah, I'm not sure.
I'm not sure where in the context, of the presentation that came in, but
maybe I can answer it this way. I hope this answers your question. Basically, when you create a you say you take a circuit emulated pseudo wire. That circuit emulated pseudo wire can be transported over a layer 2 or layer 3 VPN. Our platforms do support layer 2 and layer 3 VPN capability. If that's the question.
Okay.
Okay.
Let's see, where are we at time-wise? Is Neptune CES equipment supporting both Sync-E and PTP frequency profiles?
Yes, we support. We both support Sync-E, and we support currently support the full timing profile of PTP, and we have a roadmap for the partial timing support for PTP.
Okay. Does the Neptune solution do DS1/DS0 grooming?
It depends on the application. What we don't do is we don't do the channel associated signaling part. We're more set up for bulk transport. So if the DS0s, let's say, require they're for DDS circuits and things like that, yeah, we can that's just fine. The Neptune solution is really not optimized as a 1.0 DCS replacement. It's more of a bulk transport solution.
All right, and we had a question about some of the use cases. It says, in your use cases, does the regional carrier not provide TDM-based leased circuits to the enterprise customers, specifically in rural areas?
I'm sorry, Vance, forgive me. Can you repeat the question?
Sure. In the use cases we showed, does the regional carrier not provide TDM-based leased circuits to the enterprise customers, specifically in rural areas?
Let me go back to the picture. That may help. And forgive me if I'm kind of misunderstanding the question at all. The way I understood it is, there's a service provider and they are providing DS1 or DS3 leased line circuits to an enterprise user, and the enterprise user doesn't want to change. They want to keep their DS1 and DS3 handoff, and they want to keep paying for a DS1 or DS3 like service. So with this solution here, you can maintain the interface handoff to the business customer, and you can maintain the service characteristics. So from a customer point of view, they're still buying a DS1 lease line circuit or a DS3 lease line circuit. Their billing's the same. They're, it looks like the same service. I hope that spoke to the question. If not,
I think it did.
Just an email and we'll follow up.
Yeah. So I think that'll wrap it up for us. And to that point, I will be sending out an email later today with, a link to the replay of everything today. So if you have these questions that you didn't get answered, feel free to respond to that email, and we'll be sure to follow up with you and get your questions answered. When we do end today, there will be a brief survey that'll pop up. So we appreciate your time with that. Sam, Todd, anything else before we part ways today?
No, I just want to thank everybody for their time again, and we have a few questions that we didn't address that we will be following up with individually or later today.
Great, sounds great. Thanks, everybody.
Okay. And very good. And by the way, Elizabeth just put her information there in the chat box as well. So I'll leave this up for just a moment so you can see those details and get a hold of Elizabeth if you need to. But again, look for that email today in your inbox, link to the replay, respond to that if you have questions. There'll also be a link there back to Ribbon Communications where you can learn more about all the wonderful things Sam and Todd spoke about today. So take care, and thanks so much for joining, and we will see you next time.
Okay, take care.
Thanks.